example on each problem of these problems. It's really very simple. Okay. Now I'm going to invert all the derivative laws that I wrote for you at the beginning of our session in derivative. I will start with any exponential function. If I want to integrate, please do careful. E to a power of an f of x. In order to be able to integrate this function, you must have the derivative of the power of this exponential function. So e to the power of f of x, I'm not going to be able to integrate it unless you have the derivative of the power. This function derivative should exist. That's a condition. These are conditions in order to integrate. The integration of this form is going to be simply just only the main exponential function, e to the power of f of x plus a constant. I will give you an illustrative example shortly. The other rule, which is also really very important, if I want to integrate, please do careful. Any f of x to a power of n times dx, you are not going to be able to integrate this function unless you will have the derivative of the function inside this bracket. So it must have f dash of x. This is called a condition. This is a condition. In order to integrate, you will have to have f of x to the power of n. Don't you forget, you have to amend that the function inside the bracket, its derivative really exists. Once it is set, the answer is very, very simple. All I have to do, I will forget about the derivative part. I will take the main bracket, which is f of x to the power of n. I will move it this way. So it's going to be f of x to a power of n plus 1 divided by n plus 1 plus a constant. I'm done with it. Remember the condition in order to use this rule. Another rule, if I have, please do careful, if I have integration, take care of an f of x. There is no power in the denominator. I have a function in the denominator. I can't integrate this function unless, remember, this function doesn't have power. And I will write another rule to amend that you understand what I'm saying. This is with respect to dx. I'm not going to be able to integrate unless I have the derivative of the denominator. Of the denominator. So I have to have f dash of x. So I have a function in the denominator. Its derivative exactly really exists on the denominator. And also, it's a condition in order to integrate. This is a condition for integration. The integration is going to be really very simple. It's going to be ln for an f of x, then plus a constant. I succeeded in writing this form because the existence of this condition. Be careful that number 3 is really tricky with this one. If I want to integrate, please do take care of this. F of x to a power of n, where this power and that power doesn't equal to negative 1. We already saw if the power equal to negative 1. If you have any other number, same condition apply. I will have to have the derivative of the function in the denominator, dx. See how I'm going to treat it. I will make integration for n f of x to the power of negative n. First I will have to do this. Then I will have to be sure that the derivative of the function inside the bracket already exists. That's a condition. This is a condition. Then the integration will be simply f of x to a power of negative n plus 1 divided on the new power, which is negative n plus 1 plus a constant. Following these rules will help you out a lot in your successful treatment of most of the indefinite problems. Okay, let me give you some examples on this, then I will write a rule for the trigonometric functions. Let's start with the first one. I will give an example on it. If I want to integrate e to the power of x cubed minus 4x dx, I can't integrate this function. We can't integrate this function. We can't integrate this function unless you have this part assigned to it. 3 over x squared minus 4. This is the problem that you can integrate. Otherwise, you are not going to be able to integrate it. So if I have a function like this, I will start looking at the power. It's an exponential function. The function derivative really exists. The power derivative really exists. So the condition is satisfied. Here the condition is satisfied. So simply the answer will be I equal to e to the power of x cubed minus 4x plus a constant. You are set. This is done. Let me see it once more. If I want to integrate, let's say x squared minus 4x to a power of 3, and this is multiplied by x minus 2. In this form, I will have to check. I have a bigger bracket with a power times a smaller bracket. In order to be able to integrate, the condition is crystal clear for you. Before you integrate, you have to be sure that the derivative of the function inside the bracket is already exists over here. How to be sure about this? Just differentiate the thing and try to compare. If I want to differentiate this function, it's gonna be a 2x minus 4. If this value exists here? No, it's missing the 2. So how to handle it? Simply, I'm gonna multiply this bracket by 2 over 2. So it's gonna be, instead integrating 2 over 2 over x minus 2 times x squared minus 4x to the power of 3 with respect to dx. The 2 for the denominator, I will let it to be multiplied in this bracket, and the half I will take it outside. So it's going to be a half over an integration of 2x minus 4 times x squared minus 4x to the power of 3 times dx. The condition now is correct. The derivative of this function already exists. It's correct. The condition is satisfied. I can integrate. The integration simply will be the half will remain. I'm not going to touch it. I will take the mid bracket, which is going to be x squared minus 4x to a power of 4 divided by 4 plus a constant, following exactly what's written here in this week. This way, I can integrate successfully. If I want to integrate the function from f dash of x, please do forgive me. I will try to write it here. Okay. I will try to give an example, a small example. If I want to integrate 2 over x divided by x squared plus 1 dx. See, the denominator bar is 1. So I can't raise this denominator to be a denominator with a power of -1. I can't use this rule. So I'm going to use instead this one. In order to use this function, you have to be damn sure that the derivative of the denominator will exist on the denominator. I can see that it's already there. X squared, the derivative is 2x, so it is correct. So I simply will be ln for x squared plus 1, don't you forget plus constant. This is the main integration in direct, a little bit indirect, but if you understand them well, you are going to be in a very good shape. You have a lot of problems and the trading and illustrated examples on your canvas, on the PDF, and also on the sheets that supply to you in Canvas. So you should be in a very good position if you understand them. Okay, let me see. These are the rules that I told you about. All of them exist here, even for the arithmetic function. If I want to integrate, for example, another problem. I will go through it, but before going through this, there is just only one rule I want to write it for you. If any of the trigonometric functions, if you are integrating any of the trigonometric functions, if I want to integrate, let's say, integrate cosine, sine, tan, sec, whatever, and it's of an f of x, before integration, you have to be sure that the derivative of the argument already exists. The derivative of this function already here. If not, try to make it exist. The only thing that you have in your hands is to multiply by 2, divide by 2, multiply by a constant number, dividing with this constant number, and then you can adjust it and integrate. If this exists, if this function exists, the derivative of the argument already exists, the integration is going to be simple. I'm not going to look at the function and its derivative. I'm going to concentrate on cosine x. Well, the function that once you differentiate it, when I give you cosine, which is simply sine. So it's going to be sine of the f of x plus your constant. If you remark, this is exactly the backward steps for the derivative formulas that we did go through shortly. Let's take an illustrative example on this. I want to integrate a cosine of an x squared minus 4x, for example. I'm not going to be able to integrate this function unless I have the derivative of this function. Let's say I've given you x minus 2. Once more, before integrating, just look at this function, try to get its derivative in order to compare what exists in your problem, which is simply 2x minus 4. It's almost there, but it's missing a 2 in order to have 2 of x minus 4. So what to do in this situation? I will try to make this number exist simply by multiplying of a 2 and divide by 2. Once I do this, I will have the form exactly like the rule. It's a 2x minus 4 times a cosine of an x squared minus 4 of x required to integrate. So simply, your integration is going to be, I will let the half down. I'm sure that the angle already derivative exists, its derivative already exists. So the condition is satisfied. I will neglect the angle, I will neglect the derivative, I'm going to concentrate on cosine x. What is the function that once you differentiate will give you cosine? So simply it's going to be a sine for the main argument, which is x squared minus 4x plus. Once more, you have a lot of problems and illustrative examples in your main PDFs, which already exist on Canvas, and also you will have a lot on the main web that's treating integration in all its types. I want to give you another problem, like a bunch of smaller problems connected all together. If I want to integrate, let's say, e power x squared minus 5x plus, let's say, 2x divided by x to the power of 2 minus 5 plus 3 of a root of x minus 2. What are we missing? Plus x to a power of 5 plus 2 over an x plus 5 was just victorious. A lot of problems, you can do them all together. First of all, I will have to ensure that each part I know how to integrate it. This is going to be very, very simple. This is x to the power of 6 over 6. This is going to be 2 ln x, as I told you. There is no power on the denominator. This is going to be simply 5x. Oh, this one needs to be adjusted a little bit. I'm going to let it to be 2 of, 3 of x minus 2 to the power of a negative half. And this way I can apply the bracket to a power. If I look to the other problem, which have a function in the denominator, is no power, the derivative already exists, I know exactly the treatment of this one, which is the arithmetic function. If I look to this one, it's almost the exponential function. The power is x squared minus 5. In order to integrate, the derivative is 2x. So take care, the derivative of the power is 2x. I will have to ensure that it really exists here. So simply, I'm going to multiply 2 and divide by 2. Don't put 2 here. If you put 2 here, it means all of this are multiplied by 2, and this is not correct. I want to be sure about this part only. And in this way, the rule can be applied. So if I wear your shoe, I will try to write a bunch of the laws that I'm going to use, then I will go using them. That's I is going to equal to. The condition is already satisfied, so the answer is e to the power of x squared minus 5 divided by 2. This is the integration of the exponential part. The other part, the function in the denominator, its derivative already exists in the denominator. So the condition is satisfied. Simply, it's going to be plus ln of a denominator, which is x squared minus 5. I will go to the other problem, which is 3 times x minus 2 to the power over negative half. Same way like, as you can see, the function inside the bracket, its derivative is 1. And it's already exists here, 3 times 1. I will consider that exists. So, I will try, plus the 3 will go at the 3. I will take the main bracket, which is x minus 2. I will add 1, so negative half plus 1 is going to be half, divided by half. I will go to x power 5, so it's going to be x power 6, divided by 6. At 2 over x, it's simply 2 ln x, direct substitution. A 5 is going to be a 5 of x. Once more, don't you ever forget, plus a constant integration. You can handle whatever you need. But in integration, you can't just go integrating without knowing the rules. You will have to know the rules first, understand them, then integrate. Integration is very sensitive, so you will have to follow the rules exactly. A word by word, a number by number, and be sure in all times. Before going or studying integration, you have to study differentiation, because integration, as I told you, it's an antiderivative process. It's the inverse of the differentiation process. So you have to understand differentiation very well. This way, you will be able to integrate exactly and correctly as much as possible. Okay, let's move forward. I'm sorry if I've been too long. This, as I told you, this is going to be very, very simple. Once you know this is going to be sine of 2x over 2. This is going to be e power 3x divided by 3. This is going to be an x. This is going to be minus pi of x plus a constant. Very easy. Here, I'm going to talk about a definite integration. Before going to definite integration, I'm sorry, you will have to know how to use definite integration. Definite integration rules and a lot of examples once more really exist in the library. But the bottom line, if I want to integrate any function that's an a and b, and I have a function which is the integrand, any integrand, the function between the integration sign and with respect to the variable, it's called an integrand. First of all, it's an integration, so all the integration rules apply, except one of them. If I want to integrate this function, first of all, I will have to integrate according to the integration rules that we did go through, whatever the function in the integrand. So I'm integrating, so it's going to be f of x. I've gained the main function. Instead of adding a constant of integration, I'm going to make a substitution by b, then by a. So it's going to simply be f of b minus f of a. I will make a substitution by the upper integration limit minus a substitution in f of x by the lower integration limit. And this is going to deliver a value for me. So it's going to be a number. This number mainly represents the area enclosed between the function that you are integrating, which is f of x, f dash x, whatever, which is the integrand, starting from A to B. The number that you are getting is the area under the curve, or the area between the curve and the integration x. So if I'm integrating with respect to 2dx, the meaning you will be easily able to find the area that you want. I'm sorry, the integration that you want. But what does it represent? It represents the area under the curve that you are integrating, starting from A to B. So you will be able to get this. For example, if I want to integrate from 0 to 2 for the function 2x minus 3, for example, it's really simple. All I have to do is to integrate this part, which is going to be x squared minus 3 of x. I've integrated the main function. Then I'm not going to add a constant. Don't add a constant. I will try to substitute, replacing every x by 2, then minus replacing every x by the lower limit, which is 0. This is going to deliver the areas that I'm going to show you right now. So simply it's going to equal to a 4 minus 6. I've replaced every x by 2, minus I will replace every x by 0. So it's going to be 0 to the power of 2 minus 3 times 0. Don't have to write it. So it's going to be equal to -2. Actually, I'm going to take a magnitude or absolute for this value, which is going to be 2 over L squared. What does this area represent? If I have 2x minus 3, so if I have this is the y-axis, this is the x-axis, this is x-axis, that's y-axis. If I want to draw the function, which is y equal 2x minus 3, this is the integrand. If I want to draw this function, simply if I put x equal to 0, if I put x equal to 0, I will start from -3. If I put y equal to 0, it will come up to 1.5. Okay, so this is the line that we are talking about. We are integrating, okay, just a second please, just a second, I will make a correction, and as you can see, let me do one here, and so I have to adjust this in order to make it a little bit simpler and correct exactly. So this is one. So if we want to substitute, I'm sorry, I'm just trying, I will tell you why I did this, just so shortly. So it's going to be a 1 minus 3, which is going to equal to -2. Absolute is going to be 2 over L squared. What's actually, I've drawn the function, which is y equal to x minus 3. The area that this value represents is exactly from x equal to 0 to x equal to 1. So this is the area that you are getting, which is between the curve, which is y equal to x minus 3, and the x of integration. So this is the part that we are getting the result for. Why did I correct the integration limit in this problem? As you can see, I'm just putting anything from my mind. But you have one only condition in evaluating a correct area. The area that you should evaluate should be in one side of your x, between your curve and x. If the area encloses an area in two sides of your x, you will have to evaluate each one of them separately. Then add them together. I will illustrate it just in seconds. If, for example, let me do this example for you. If I have y equal simply x minus 2 times x plus 3 for this example. I want to evaluate the area which is between or from x equal to 0 to x equal to 4, for example. First of all, in order to get a successful evaluation of this area using definite integration, I will have to draw this function first. Drawing this function, you already know about quadratic functions. So if I want to draw this function, simply I will have 2 points. That's the intersection of this function with the x-axis. So all I have to do is to get the intersection of the main function with the x-axis. I will try to solve these two equations together. Y equals 0, which is the equation with the x-axis, and y, which is equal to x minus 2 or x plus 3 before integrating. This is going to 0 equal to x minus 2 times x plus 3. That's x equal to 2 or x equal to negative. I'm sorry, equal to negative. I'm going to go to the x-axis. This is negative 3, and that's positive 2. The area, or the function that I'm trying to represent, it's going to pass through negative 3 and 2. So I'm going to just use simple number between in this interval. Let's say 0. If I put 0 here, so it's going to be 0 times negative 2, it's going to be negative. 0 plus 3 is going to be 3, so you will have negative value. So actually, your quadratic function is like this. This is the function that we are talking about. It's cutting the x-axis at negative 3 and then at positive 2. The vertex is in the negative side. So I want to integrate or to evaluate the area between this curve and the x-axis from 0 to 4. If you rock, this is x equal to 0. This is the first integration limit. And that's x equal to 4. So actually, let x equal to 4 be here in order to be able to show to you exactly what are the areas that we are interested in. Okay. From 0 to 4, so it is this area plus this area. It's a fatal mistake. Just to integrate from 0 to 4 for this function as a whole, x minus 2 times x plus 3. This is not correct. Don't do this. This is not correct. What should I do? I will make this integration on two parts. I will make first the integration from 0 to 2, then from 2 to 4. Take each one of them without absolute value, then add them together in order to get the correct area representing these two parts. So simply, if I want to integrate, first of all, get this function as simple as possible. So actually, I'm going to integrate x times x, which is going to be x squared, negative 2x plus 3x is going to be plus x minus 6. This is the function that we are going to integrate. X squared, negative 2x. Okay, looks fine for me. I will start to get the integration. I is going to equal to integrate. First of all, I will take this part, which is on one side of the integration x. So I'm going to integrate from x equal to 0 to x equal to 2. This part alone, which is for x squared plus x minus 6. Then I will add on it the integration from 2 to 4. This part for the same function, which is x squared plus an x minus 6 dx. The integration is very, very simple. I will integrate each one of them separately, evaluate each one of them separately, then I will add these two numbers on each other. Remember to take these values without sign, to take them absolute values. This is for area number 1, and that's for area number 2. So integrating, it's going to be x power 3 over 3 plus x squared over 2 minus 6 of x. Then I will substitute by 2, then 0. By being plus, integrating for this part, which is going to be simply like x cubed by 3 plus x squared over 2 minus 6 of x. Then I will try to substitute from 4 to 2. Start by the upper limit minus the lower limit. Get an absolute value for this area, which is A1, plus the absolute value of area 2, and this is will be the required value for it. Once more, I'm trying to summarize this part for you. You will have a lot of problems. Please go through them in the main vid of this part. I hope I succeeded in delivering the amount of knowledge that's really exists here. You will have a lot of these problems in level 4, inshallah, and the coming 4 engineering mathematics, inshallah. Here he is asking you about the area enclosed between the curve x squared minus 1 and the x-axis, also the y-axis from x equal to 0 to x equal to 4. You will have to first to draw, please do draw this function first before integration. So if I want to integrate this function, it's very simple. I will try to go through it with you, and the previous example was a little bit harsh. This is the x-axis. That's the y-axis. I want to draw y equal x squared minus 1, which is simply a quadratic function in its simplest form, which is going to be symmetric about the y-axis. The y-axis equation is x equal to 0. If I put x equal to 0, so it will start from negative 1 and go up. This is the function that we are talking about. I want to find the area between x equal to 0, from x here equal to 0, till x equal to 4. So I have a part, I have some of my area in this side, the other one is already here. So if I continue this branch, this is going to be like this. This is the area that we are talking about. I will need to know exactly what is the value of this function, or what the value is. Simply, in order to get a solution of this function, or of this, at this point, try to solve y equal x squared minus 1 with the curve which is the x-axis. The equation of the x-axis is y equal to 0. So simply, I'm going to solve 0 equal x squared minus 1. That's going to deliver x squared equal positive 1, which is going to lead to x equal positive or negative 1. And it makes sense. The curve will cut here at negative 1 and here at positive 1. Now I'm ready to get my exact area exactly. This is going to be A1, this is going to be A2. So all I have to do is to state that I'm going to integrate from 0 to 1 for the function which is y equal x squared minus 1. So here it's going to be x squared minus 1 with respect to x. Then plus integrating from 1 to 4 for the same function which is x squared minus 1 with respect to the x. So it's going to be simply x cubed over 3 minus x. Then I will try to substitute first by 1, then minus 0. Then plus, same way like x cubed over 3 minus of x. Then I will try to substitute from 1 to 4. Simply try to get these values. So it's going to be 1 over 3 minus 1. Don't you forget an absolute value. Minus 0 is going to be 0. For this part, it's going to be plus. Make an absolute. It's going to be 4 power 3 over 3 minus 4. This is the substitution by the upper limit. Minus, same way like it's going to be 1 over 3 minus 1. Then get all these values. Don't you forget. This part is absolute. This part is absolute. And then you will get the correct area. Drawing correctly, you will have a mark. Understanding that you have the intersection points that separates the negative part from the positive part, you will have a mark. Separating your integration into 2 parts, it will have a mark. Then finally getting the final answer, it will have a mark. So please try to go through them. Once more, we have a lot of illustrative examples in the main vid of this part and on the PDF. Please don't watch the vids without trying to resolve them. If you have any questions, more than welcome to come at the office hours. You already know where we exist, either me or any of our IFP Mathematics 2 team. So you can meet any one of us, ask them about any question that you like, and we will be very happy to deliver whatever you need. And I want to say, that by the end of this lecture, that we are all here to make your life easy. Okay? If you have any questions, you are more than welcome to join me. Thank you. Appreciate it. I hope this video you like this video, and I hope you all pass and have good grades. Thank you very much. Enjoy the rest of your day. I'm very happy to be with you today. Thank you.